Hey, welcome everybody. Just want to let you know that I'm doing well, and hopefully you're doing well and taking care of your parents as much as possible, helping them out, not hurting your siblings, helping out neighbors if you can. That'd be great. All right. First of all, next lesson we'll be doing something different. We won't be working in the next gen, so I just want to let you know about that. Today, though, is a culmination of everything that you've done in next gen, so it's actually a test. And just to let you know, there's 15 questions, all right? And what I've done is, for you guys for notes, what I've done is in this video, I go through kind of like an example of each problem. I have 15 examples, okay? 15 examples, starting with number 1. And so you just watch the video, and when it goes over number 1, you keep it in another tab. Keep this video in another tab, go to Next Gen, start the test, and then click on this video, and I go through each problem. Not exactly the same thing, but very close to it. Okay? Also have a calculator on hand to assist you. And tests are a category that's really lowered many students. So this is your chance, those who are low, to raise it up. Okay? And I've tried to assist you as much as possible by showing you each problem, an example for each problem. Okay? So don't shut off the video. Keep it going. Go to Next Gen. Do the test with the calculator. And I will put up the problem just like each one of the problems that you are doing. Okay, 15 examples. 15 problems. Okay, that's all I have to say for now because it's kind of lengthy. And I'll let you get to work. Thanks for being here. You guys are doing a great job. You make me proud. You make me very proud. All right, so next lesson, we'll go ahead and we're going to do something different. Okay, we'll see you later. Take care and be safe, okay? Be safe. Okay, so here's one of my classes, and it has 37 students in there. 16 out of 37 have raised their grade, have raised it. Now, some people raise their percentage, but they actually raise their grade. So, for example, from a C plus to a B minus, or F to D, or B minus to A minus. Okay, so even though there are some who also raise their percentages. Now, there are some people who received an A, already had an A, and therefore they could not rate, like A minus. Okay, it did not. It's probably an A plus now, but the grade didn't change. It's still an A. So you can see all these students who have participated have increased their grades. And so I just want to encourage you, if your grade has not gone up, you have your chance today because now we're going to be doing a test, and this testing category should raise quite a few of your grades. Okay. Okay, so consider this your test notes, and then you can just look at my problems as you do your problems. Keep a tab open for this video. Okay, on this next problem, number 1, it's similar to one we've done before, where you have proportions, 1 sugar to 3 water, how much sugar to 1 water. Okay, and basically we're finding unit rate, and we could use cross products, 3x, 1 times 1, then we divide by 3, and there you have your answer. Okay, so the key is to set up, first of all, just set it all up. And it doesn't matter where the x is, doesn't matter if you have water over sugar, or sugar, water, sugar, water. It doesn't matter. It'll all come out the same. So now to our problem. Let me just read it quickly. It says Nolan uses 1/6 cup of lemonade. So 1/6 cup of lemonade for every 2/3 cup of strawberry juice to make strawberry lemonade. Enter the number of cups of lemonade if he already has, Nolan uses for 1 cup of strawberry juice. Okay, so we have already 1/6 cup of lemonade. So notice I have my units written down. L for lemon, SJ for strawberry juice, lemon strawberry juice, lemon strawberry juice. How much lemon? 1/6 cup is for every 2/3 cup of strawberry juice. And we want to know how much lemonade for 1 cup of strawberry juice. That is setting it up. Okay, then we can use cross products. Now remember on the other problem, when we did cross products, like 3 times x is equal to this 1 times 1. And then we divide by 3. Notice whatever is diagonal of the x is going to be at the bottom. And the other two are on top. See that? Right there. That's the way it works out. So you know what? We'll just use that same principle on our problem. So it's basically going to be this times this equals this times this. One-sixth times 1 is going to be 2/3 times x. You know what? I'm going to move it over. But what happens is, if you divide by 2/3, you divide this side by 2/3. So what do we usually have? What do we have here? 1/6 divided by 2/3. We just take the top divided by the bottom. So I'm just going to write that right here. 1/6 divided by 2/3. So whatever your fractions are, just divide them. 1/6 divided by 2/3. And if you remember, we leave this alone, 1/6. Change it to multiply. To use a reciprocal. Multiply by the reciprocal. So let's see what we have here. We have 3 over 12. Hey, 3 goes into both of those. 3 goes in here once, and 3 goes into 12 4 times. The answer is 1/4. 1/4 cup. So again, all you need to really do is just divide. 1/6 divided by 2/3. 1/6 divided by 2/3. That's what it comes down to. And then change, flip. Multiply by the reciprocal. Okay, on number 2, it's asking for unit rate. It wants to know what the unit rate is. So looking at a graph, remember you have to find out where an intersection is. And there isn't, this is close, but not quite. That's close, but not quite. That looks very close, but it isn't. If you look closer, it's not. This is the one where the line goes through an intersection. So I can use this 10 and this 420. So I just take my y over the x. Y divided by x. This is my y, 420, and this is my x, 10. 420 divided by 10 is 42. This is the unit rate. Y over x. Okay, on number 3, it's going to ask you, you're going to have some ordered pairs here, and it wants to know which ones are proportional. It says select all. Select all. That means, so there could be more than one. And so what we want to know is y over x, are they the same? For example, here, we have 5 over 1. Is that the same as 15 over 2? Is that the same as 20 over 3? 20 over 3. That's the question. Are those equal? If they're equal, then this is proportional. 5 divided by 1 is 5. 15 divided by 2, you can just use a calculator. It comes out to be 7.5. Hey, these are not the same. This y over x is not the same. It doesn't work. Therefore, this is not the correct answer. Forget this. That one's not going to work. Okay, what about this one here? Okay, y over x. I'm going to use y over x. Are they all the same? Is 3 over 4? Is that the same as 6 over 8? Is that the same as 9 over 12? That's a question. Are they all the same? Right? We're using the y over the x. The y over the x. Are they all the same? And this, 3/4, okay, let's just leave it like that. 6 over 8, that could be reduced. 2 goes in there 3, 2 goes in there 4. On this one, 3 goes in here. 3 goes in there 3, 3 goes in there 4. Hey, look, they're all 3/4. It works. They're all the same. This one is one of the answers. I don't know if it's all, I don't know about the others, but this one works. Okay, now sometimes they may be fractions. So if that's the case, if you want to, you can just use a calculator. Make them decimals. Like 1/4 is 0.25. 1/2, 1 divided by 2 is 0.50. 3 divided by 4 is 0.75. You usually use a calculator. Just say 3 divided by 4. All right? And then once you get that, now, so this is 0.25. So I'm going to take the y over the x. 0.25, this is 0.25. 0.25 divided by 4. Is that the same as 0.5 divided by 8? Is that the same? Is that the same as 0.75 divided by 12? This was 3/4, so that's 0.75. Are they the same? And you know what? They are the same. They are the same. So guess what? It's proportional. It's proportional. Okay, number 4, let's go to our notes on this. You're going to be given some graphs, and you have to say whether they're proportional or not. Does it represent something proportional? And remember, the relationship is proportional if you can draw a straight line from the origin through the points. So if you can go from 0, 0, straight line, through the points, then it is proportional. And if you notice, this one is not a straight line, therefore, it's not proportional. It's not proportional. This one is a straight line, but it's not through the origin. This is not proportional. This one is proportional. It goes through 0, 0, and it's a straight line. Okay, that should help you out for that problem. Okay, problem number 5 is the same as 3. Okay, so you just have to figure out, is it proportional or not? The only thing is, it probably has fractions in it. And if it has fractions in it, you can just use your calculator and just use division. Make it a decimal. That's okay. Okay, number 6, you're going to be setting up like this, using proportions. So it says you have a table here of sugar and water. And the question is, how much is it for 1 cup of water? 1 cup of water. So if we look at this, if I rewrite this, we know it's going to be, okay, so you got to figure out how much sugar for 1 cup of water. All right, so basically you're just going to divide, aren't you? You have this, 1 sugar, 3 water. How much sugar for 1 water? I just took the y over the x. And so what does it end up being? 1 divided by 3. It ends up being 1/3 anyways. But in case it isn't exact, in case this isn't a 1, you can still set it up just like this, and it should come out fine. Okay? Number 7 is just the same as number 6. The only difference is we're talking about maybe some fractions involved. Fractions involved. So you want to know, this is how much apples for this many bananas. How much for 1 cup of banana? So notice I set this up. Apples, bananas. How many apples for 1 banana? Basically all we're doing is dividing. This top fraction divided by the bottom fraction, or mixed number. And to do that, let me zoom in here. Okay, to do that, it's this divided by that. See, I just wrote it sideways. I use a calculator, a times plus, that's 152, times plus, that's 38. Now remember, division is the same thing as multiplying by the reciprocal. You have to flip it. Multiply by reciprocal. So I flipped it, and it turns out that 5 goes in there once, 5 goes in there 7, 4 goes in there once. I'm sorry, 38 goes in there once, 38 goes in there 152. And you can use a calculator when doing this, okay? You can use a calculator. Okay, number 8 is set up just pretty much the same as the other, except we don't have it in a table. They just put it like this. All right, so, and it has papaya juice and orange juice. And they want to know how much for 1 cup of orange juice. All right, so I just set up those mixed numbers there. I just rewrote it. this is what we have. This much papaya for this much orange juice. How much papaya for one orange juice? So it's this top number divided by the bottom number. I wrote it sideways, the top divided by the bottom. Now I make them fractions, times plus, times plus. Now I'll have to multiply by the reciprocal. I multiply by the reciprocal. I just flip it over. And then you can reduce from there. And use your calculator to help you reduce. All right, number 9 and 10, they're both the same type of problem. So we'll do it one time. It tells you it's proportional relationship, and it wants to know like how many miles driven versus how much gas. All right, and so it wants to know, determine the proportionality and enter it in the form of y equals something x, right? That's basically the unit rate. And so to figure out that unit rate, we use y over x. Y divided by x. It doesn't matter which one you use because it is proportional. It doesn't matter. But if I chose 16 over 2, this y over this x, that's 8. Or this one, 40 divided by 5, that's 8. 8 is the unit rate. But you need to write it as an equation. So we will write it as y equals 8x. Okay, so you have to calculate this 8, but now you need to write it in y equals 8x. And don't use capital letters or else you'll get it wrong. Use small case letters, lowercase letters for y and x. So that is the answer. Okay, on number 11, it says to graph. This graph shows a proportional relationship. It's proportional. It goes through 0, 0, and it's a straight line. And it asks us to find the constant of proportionality. That means the unit rate. And then write it in the form of y equals kx. So y equals something x. And you have to figure out that something. Okay, so looking up here, you may have to expand the graph to look. Look where the intersections are. Like there's no intersection there, but right here there is. See that? 2 and 1. Or this one right there. That's 4 and 2. Okay, so anyways, you can see where the intersections are. You can use any one of those points. Any one, because they told us it's proportional. So I'll just use this one here, right? And this is my y, and this is my x. Y over x. And y over x is 4 over 2. I could use this one, that point. Well, 4 divided by 2 is just 2 goes into 2. 2 is the number that goes there. 2 is that number, excuse me. So we would say y equals 2x. This is the answer because they say write it, enter the equation, an equation in this form. So you need to write, again, smaller case letters. Don't use capital letters. Y equals 2x. Okay, number 12 is a percentage problem. We did this one before. Some person drinks so much and they have so much left over. How much do they have left over? What percentage is it? What percentage? So if I have 12 total, they drank 10, that means you only have 2 left, right? 2 out of 12. And make that a percent. So you just make 2 divided by 12 into a percent. Okay, and it turns, but you have to round it off. That's the key right there. That's where people make mistakes. You need to round it off to the nearest hundredth. Nearest hundredth. Okay, so in this case here, 2 divided by 12 has 0.1666. It just keeps going. All right, well, that's 16.666, right? So this is where you're going to stop. You look to the right, 5 or more, it goes up. It does. So the answer is 16.666. 7. All right. Another quick example. Someone had 32 ounces. They drank 15. They got 17 left over. 17 out of 32. What percent is that? So if I use a calculator, I get this big long number. I move the decimal over twice. And so this is where I need to round off. I look to the right. If it's 5 or more, it goes up. It is 5 or more. It goes up. All right. And if you did this method, and you could see you're going to multiply by 100, there's the number, but you want to round it off to here. So you look to the right, 5 or more, it goes up. Number 13, find the constant. Okay, it says it's proportional. That means every y over x is the same. It says find the constant of proportionality, which is y over x, and then write it in this form as an equation. Well, if I do that, if I take a y over x, like this one, 44 over 4, that's 11. If I take this one, 55 over 5, that's 11. So the answer is y equals 11x. That's our final answer. Okay, number 14. We have this graph right here. And they have B for bill and N for number of users. Instead of X and Y, they have B and N. So they want to know what the rate is, that rate, unit rate. So let's see, we have to figure out, this is kind of challenging because you may have to expand your screens, make it a little bit larger, but you're looking for where the line goes through an intersection. And I can see one right there for sure. The other ones are hard to tell, but they don't quite go through. But this one I know for sure does. And so if you take those two numbers, and I think we did this one before, 420 over 10, that's 420 divided by 10, that's 42. But they want you to write it, I'm sorry, you can see that. Expand out here. But they want you to write that using the letters B and N. I know, it's crazy, but that's what they want you to do. B for the bill and N for the number of users. So B and N instead of Y and X. So you put that number right there, and that is why it comes out to B equals 42N. Now, they tell you that right here, to write it in B equals PN. Okay, so use, again, lowercase letters, B and N, and your unit rate right there. Okay, last one. This has to do with percentage. Something's cost $120. It was discounted to $84. How much did it go down? What percentage is that? So it went from $120 to $84. And to figure that out, you take the difference over the original number. So you subtract the two, all right, and that gives us 36. And the original, we started with 120, but it went down. So we started with 120, and it went down to 84. So that's 36 divided by 120. The original goes down below. Use a calculator. 36 divided by 120 is 0.3. What percent is 0.3? You move it over two spaces, it's 30%. The answer is 30%. That's how much it decreased.